Alright, 3.4. Building quadratic models from verbal descriptions and from data. Example 1. The marketing department at Texas Instruments has found that when certain calculators are sold at a price of P dollars per unit, the number X of calculators sold is given by this demand equation. Alright, so if you think about it, your revenue is going to be the number of units sold times the price. So for example, if you are selling calculators at $100 per calculator and you sell 5 calculators, the amount of money you make is 5 times 100. If you sell calculators for $10 and you sell 50 of them, then the amount of money you make is 50 times 10. Okay? So your revenue is going to be the number of units sold times the price. Now we know that X equals 21,000 minus 150P. So I'm going to plug that in for X to get everything in terms of P. Okay, so now I have an equation in terms of P. I can distribute the P if I want to. There we go. So here is my equation in terms of P. Alright, part B. What is the domain of R? The function R is a quadratic function. Okay? And as you guys know, quadratic functions have domain of all real numbers. Alright. What unit price should be used to maximize the revenue? Alright, so because we're looking for whatever will maximize revenue, we're looking for the maximum. If I rearrange this equation, I'm going to have R of P equals negative 150P squared plus 21,000. Now if you think about it, this negative means that the parabola opens down. Okay? I want to find what the maximum is. Alright, so this is how we do that. I'm going to use the equation this time. My H is going to equal negative B over 2A, which in this case is 21, oh, I forgot the P over here, sorry. 21,000 over 2 times negative 150. Negative. So this is going to be 21,000 over 300. The negatives cancel out. You end up with $70. Okay? So that is the unit price that should be used if you want to maximize revenue. Okay? Now, if we charge this price, what is the maximum revenue? Well, now we just got to plug it in. So this is part C. Part D, I need to find R of 70. So this would be 21,000 times 70 minus 150 times 70 squared. And you guys all have calculators. You could just plug it in if you like. You should end up with $735,000. Alright, E. How many units are sold at this price? Okay, the number of calculators sold is given by this demand equation, the equation we started with. 21,000 minus 150p. And we know what P is 70. P is 70. So I'm going to plug that in. If you do all that, you should get 10,500. So this is the number of units sold. And then the last step is to graph it. You could just use a graphing calculator if you want. That's fine with me. You'll end up with something that looks kind of like this. Let's see here. I'll make this 100,000. So 200,000, 300,000, 400,000, 5, 6, 7, 8. And let's see here. Let's go up by 14s. 14, 28, 42, 30, or 56, 70, 84, 98, 112, 126, and 140. Okay. So the maximum is at 70. So let's see here. 70, 735,000, so that's pretty close to 800,000. Okay, and goes from here all the way to here. Something kind of like that. Okay. Your graph does not have to be beautiful as long as it's accurate. That's fine. I'll let you try that with this one. Alright, example 2. A farmer has 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that enclose the most area? Okay, so best thing to do here is to draw a picture. I'll call this length and this width. He has 2,000 yards to put around the perimeter of this rectangle. Now, if you guys remember perimeter, the equation is 2L plus 2W. So this all has to equal 2,000. Okay? Now, the area is going to be length times width. So the first thing we want to do is we want to eliminate a variable. Let's get things in terms of W. So I'm going to take this equation over here, and I'm going to solve for W. I'm going to subtract 2L from both sides. Oops. And I'm going to divide by 2. So W equals 1,000 minus L. I'm going to plug that in here. Well, I guess we're getting things in terms of L, not W here. L times 1,000 minus L. So we have an equation in terms of L. I'll distribute the L. We've got, I'm going to skip a step here. I distributed the L, and I put the negative L squared out in front. Okay? Now, hopefully you guys can see, because this is negative, we have a parabola opening down. We want to know what encloses the most area. That's a maximum. So we need to find the maximum of this parabola. So, once again, I'm going to look for my H. So I've got negative 1,000 over 2 times negative 1, which gives me positive 500. And then if you plug that in, you should get 250,000. Okay? So, the largest rectangle that can be enclosed by 2,000 yards of fence has an area of 250,000 square yards, and its dimensions are 500 yards by 500 yards. Okay? Alright, and the reason we know it's 500 yards is because if you plug this in for L, 1,000 minus 500 gives you W. So the width is 500, the length is 500. Alright, this one is pretty much the exact same thing, except now you have 400 yards. Example 3. A projectile is fired from a cliff 500 feet above the water at an inclination, oh, this was supposed to be a degree sign, sorry, of 45 degrees to the horizontal with a muzzle velocity of 400 feet per second. In physics, it is established that the height h of a projectile above the water can be modeled by this equation, where x is the horizontal distance of the projectile from the base of the cliff. Oh, I forgot the figure here. I'll draw the figure for you guys. Let's see here. Here, I'll just pause it and draw it. Alright, there's the projectile. Okay. Now, a couple things we're going to find here, and I guess I forgot to write these down too. They want you to find the maximum height of the projectile, and they want you to find how far from the base of the cliff will the projectile strike the water. Okay, so this one, here we're just looking for the maximum. We have the equation. I'll write it down here. We just need to find the maximum. So we've got x equals negative b over 2. I'm going to use x instead of h. It's pretty much the same thing. Let's see here. So 1, we've got negative 1 over 2 times negative 1 over 5,000. Okay, so because this is the bottom of the denominator, it's going to move to the top, and the negatives cancel out, so I've got 5,000 over 2, which gives me 2,500. Alright, so the maximum height of the projectile, or actually this is the vertex. The maximum height of the projectile will be whatever we get when we plug this in. So h of 2,500 this should give you 1,750 feet. Okay? So, this was my x value, and when you plug it in, you get your y value, which is your height. Okay, how far from the cliff will the projectile strike water? Okay, so if you look, it's going to strike water where y equals 0. Or in this case, where h of x equals 0. So what I'm going to do is I'm going to set this equation equal to 0 and figure out what x is where y equals 0. So let's see here. We've got negative 1 over 5,000 x squared plus x plus 500 equals 0. Okay. I'm just going to use the quadratic formula. Negative b plus minus the square root of b squared minus 4 times a times c all over 2 times a. And I trust that you guys can all make this calculation. You're going to get negative 458 and 5458. Okay, discard the negative solution because you can't get a negative distance. The projectile is going to strike the water 5,458 feet from the base of the cliff. There you go. Alright, and I'm going to leave the rest for the next video.